Hello, welcome back to Cracking the Cryptic and a puzzle called Sorry, That Sum Is Taken. I will try and explain the rules to this in a moment. It's a very interesting idea. It's by Phoenix Aki, who has featured 2 or 3 times on the channel before and who did this puzzle as a secret Santa for Sudoku, another name we've featured many times on the channel. So we'll see how it goes. I'm intrigued by the principle at play, which I haven't quite seen before. And I'll explain the rules in a couple of minutes. I will use those minutes to tell you about all sorts of things connected with the channel. So streaming on Monday nights. We've just done one of those and there'll be another one along next week. We're doing the Blueprints house at the moment. It's great fun, but I think we knew when we finished the first part of the game that we'd either stop or there'd be a lot left in it, and it's the latter. So people do seem to be enjoying it, and that's why we keep going back. We're also, of course, there is on Patreon the monthly competition, which this month is Off by One by Panthera, a calendar of puzzles, 13 puzzles, great fun, and have a go at that. If you win, you might win the prize of solving a puzzle with Simon in a collaboration video. So, as Don Ferguson did, that appeared last week on the channel. And of course, crossword masterclasses every Friday as well. But there are more crosswords on Patreon, difficult cryptic ones. And then there's also connections and gridogram there as well. So check it out. Loads of good content. And our apps feature a lot of that too. We do have Line Sudoku and Killer Sudoku. Domino Sudoku is almost relevant too. And Classic Sudoku too, the latest one. And the Worms. So loads going on. But what are the rules of Sorry, That Sum Is Taken by Phoenix Aki? So normal Sudoku rules apply. Putting 1 to 9 in every row, every column, and every 3x3 box as normal. Good news. Digits in dotted line cages must sum to the number or sum given in the top left corner of the cage. So these two must add up to more than 12, greater than 12. And what else does that mean? Region sum lines, box borders split blue lines into segments of the same sum. So those two add up to the same sum as those 5 and those 2. And now there's a uniqueness rule, a sum uniqueness rule, not sort of the uniqueness that we solve for. First of all, I'm going to do the black and white dots. So on that black dot, 1 digit is double the other. On this white one, there's a difference of 1. Now, each sum can appear at most once in the puzzle. This rule applies to killer cages and region sum lines. For example, if a region sum line is determined to have its segments sum to 6, no other line can do the same, and then no cages can sum to 6. So there are a number of cage totals and region sum segment sums, and they all have to be different in this puzzle, which is an intriguing rule. I've never really seen a difference rule play between lines and cages at all. But those are the rules. Give it a try. I'm going to start now. Let's get cracking. What do we do? Okay, I'm going to focus on single cell sums, I think, as sibilant as that phrase is, and therefore a bit of a tongue twister. Let's colour them. I've got 9 colours on my palette. If I say that's one sum, obviously both cells at each side of this line have the same total. That's a different sum, not just for Sudoku reasons, but for the rule. That's a 3rd one. That's a 4th one. This single cell cage is a 5th one. And that's a 6th one. Now, that's 6 different sums that are all less than 10 because they're single Sudoku cells. Now, the sum of this cage is 8. So that's kind of a 7th one of these. Now, this isn't a lot of use yet. Yes, it is. Yes, it is. Here are the 8th and 9th, of course. Just because these lines run to more than one cell, they cannot have a total of more than a single cell unit. I'm going to make that one red. Yeah, I mean, each segment of this adds up to red, which is a single cell in box 5. So it must be one of these units from 1 to 9. And let's make this one yellow. And that's all of my 9 colors used up. And that means that all of my 9 sums from 1 to 9 are represented by one color here. Blue is obviously 8. We don't know what any of the others are. We can obviously find out that in the case of yellow and red, the sum has to be at least 3. That's not very interesting at the moment. I think what might be more interesting is looking at the sums that go over 9. Because how many more can we have? In a 2-cell cage, we can go up to 17, 9 and 8. And we've got 1 more, 2 more, 3, 4, 5 more. But this one can only go up to 18 because of the less than 19 total. So our colours are 1 to 9 as totals. This line is another one that is a 2-cell sum. And then we've got some 3-cell and 5-cell cages. Oh, but look at the totals. This line has got a 5-cell segment. This is at least 15. This is at least 15 because the cage itself is sort of a 5-cell segment. These two are at least 15 because they say more than 14. So between these 4 units, we've got 4 digits from between 15 and 18, haven't we? Yes, this one can't go over 17. In fact, this one is 15, 16 or 17 based on 5 cells measured against 2. This one is 15, 16 or 17 based on the indication in the cage and the maximum it can be. And so is this one. Now, I don't have any sort of colors to give them, but these 3 lines are in some order 15, 16 and 17. And this cage, which must be over 15, but has to be less than 19, is not allowed to be 15, 16 or 17 and must be 18. I'm going to need some lines. That's what I'm going to need. Let's get the pen tool out. Right. I'm going to make this one a sort of yellow line. That's the 18. Then we've got, not blue, let's do red. We've got 15, 16 and 17 in red lines. Now, what are the ones below 17, 16 and 15? We've got 14, 13, 12 and 11 available, and 10 theoretically, but I don't think 10 can be in any of these cages given their totals. This one is definitely an odd total, and it's more than 12. This must be 13. We know it's an odd total because of the white dot, meaning that one of the digits on it is even and one is odd. And we now know they add up to 13 and they're consecutive. So they're a 6-7 pair. Now the 8 cage can't be 6-2 or 7-1. It must be 5-3. What do we know about this line? We know that it adds up to 15, 16 or 17. It's got to have 1 and 2 on it. And I think it has to have 3 on it. If it didn't have 3, the minimum is 1, 2, 4, 5, 6, which is 18. Too many. Because this is the 18 line, this yellow one. This one is 15, 16 or 17. It's definitely got 3 on it. And there's a 3 that can't be in those cells because of this 3-5 pair. So the 3's on the black dot, obviously with a 6. Now the minimum, well, actually, what digits could we possibly put in these cells? 1, 2, 4 are allowed, but 3, 5, 6 and 7 aren't. If we tried to use an 8, the sum of the line would go well over 17 and break these bits. So this is a 1, 2, 4 set. And we now know that this red line definitely adds up to 16. So these other red lines are 15 and 17. One of them is a 9-8 pair. Don't know how to use that. Oh, yes, I do, because I've got to put an 8-9 pair in column 1. And now this can't be a 9-8 pair without breaking that cell. So this is the 9-8 pair. This is the 17 line. That was the 16 line. This is a 15 line. It uses whichever one of 9 or 8 that doesn't use. And it's a 15 sum. How am I going to remember that? Let's give it a different color of line. And somehow I'm going to remember that green is a 15 line. I'll give this a different color of line, 17. I don't know if your synesthesia agrees with me that it's reasonable for 17 to be a pink line, 16 to be a red one, and 15 to be a green one, and 18 to be yellow. Okay, well that's good. This is good. Something has happened. We've made some progress. Now, is it worth thinking about this tower? I think it's too high to think about. Oh, let's think about these cages. Now, what did they... We had a 13 cage. That needs a colour, clearly. And these, we're allowed... Oh, over 12, but not 13. Oh, well, it's 14. It's not allowed to be 15. It is 14, isn't it, this box? It's 14. And it doesn't have a 6 in it. Perfect. So that's a 5-9 pair. Now, this is over 10. What have we used? All the colours are 1 to 9. And then we've used everything from 13 upwards. 13, 14, 15, 16. Oh, 16. I'll come back to that and these in a moment. 17. But this is 11 or 12. And well, hang on. It can't be 9, 3, and it can't be 5, 7. If it's 12, it's 8, 4. And if it's 11, it can't be 9, 2, 5, 6, or 3, 8. So it's either 4, 7 or 4, 8, and there's definitely a 4 in it. Now, I said I was going to come back to these. Perfect timing. These add up to 16. So these are both 9, 7 pairs to make that work. And now we take 7 out of that cage, and this cage adds up to 12. I don't know what colour you associate with 12. Let's make it grey. 9-7 pair makes this digit an 8. That makes this one a 9. This green line was going to add up to 15. That's now an 8-7 pair. This is a very, very neatly done puzzle. Now in the top row, 3, 6, 4, 8, 5, 9. This one can't be a 7, so it's 1 or 2. This one can't be a 4, so it's also 1 or 2. And that is a 7. 7 is the purple digit. Now, down here, 7, 8, 9 can't be in those cells or in these cells. So 7, 8, 9 are kind of sequestered into a little 2x2 unit there. This digit can't be 7 because that would repeat 7 in both orange and purple. In fact, these digits in this box are from 1, 2, 4, 6. So these ones on the lines are also from 1, 2, 4, 6. 6, 7 are a pair there, so that one can't be 6. Now, we're going to have to think about these coloured numbers now. We've got 8. I think we've done all the bigger ones. We've done 8. We've got 8. We've got 7 now. 9 can't go there. 9 can't go here either because of this. This is 9, 7, 4, 8. This is 1, 2, 3, 5, or 6. Never scared to over pencil mark. Now, 9 must be in one of these 3 cells, mustn't it? Because we've still, no, it could, yes, it's not allowed to be there by 987 rules. In fact, that's 1, 2, 3, 4, or 6. Can't be a 5 up there. Yeah, I'm not sure I'm doing the right thing, but let's just keep focusing. Oh, these digits are made up from 1, 2, 3, 4, 5, 6 because they can't contain 7, 8 or 9. Is that any use to determining what these are? Not really. We've used 9. No, we haven't used 9. One of these is a 9. Oh, well, that either means that digit is a 9 or one of these pairs is a 6, 3 or a 5, 4 pair. That's not actually wildly helpful. 8, 7. This box can't have 7 in it by Sudoku because of the 7s there and there. So one of these cells is a 7. It can't be red, yellow or orange because that would replicate the cell in pink. So we can place 7 there. That gives us the 8, 7 pair at the bottom, the 8, 4 pair at the top. We knew there was a 9 here. Now, we know that this line adds up to 18, plus 7 is 25. These 3 add up to 20. I'm using a secret there that I happen to know that every row, column and box 5, all boxes, add up to the same total. It's always 45 in a Sudoku. So share that wisely. Now, we know that these add up to 20. They include a 9. The other 2 add up to 11, and they're not 9, 2 or 7, 4, and they can't have an 8 in. In fact, there must be an 8 in one of those cells. In fact, this cage is 1, 2, 3, 4, 8 if it's adding up to 18 and it's got an 8 in. So that is quite useful because it means that the rest of the digits in the box are 9, 5 and 6, and that's how I was just about to work out from the other end how we got to the 9, 5, how we got to 20 in those 3 cells. So yellow, red and orange are 9, 5 and 6. So none of these grey, blue, grey, light blue, green or purple can be 9, 5 or 6. So I'm taking any of those digits out. These are both from 1, 2, 4. That's from 1, 2, 3. That could be any of them. There's a 6 in one of these 2 cells in box 4, so that digit can't be 6. So yellow is 5 or 9. Now, what about this row? Is that going to tell me something exciting? There's an 8 X-wing, so 8 has definitely been used in the row. 7 has not been. One of these digits is a 7, so it can't add up to 5. That must be a 7-2 pair. This digit is a 9. This pair is now a 5, 6 pair. That's going to fix the cell at the end. That's a 3. This is now not a 3. 3, 5, 6, 2, 7. The only place for 9 in the row is here, and the only place for 8 is definitely here. Oh, trying to get rid of 8. There we go. So 5 and 6. This red pair, oh no, first of all, this pair adds up to 9, not using 8 or 7. So it's either 3, 6 or 4, 5. This pair adds up to 5 or 6, because that's what red is. This cell is also 5 or 6. So 9, 8 and 7 have all been forced into this cage, which adds up to 24. Now, this cage cannot be a 24 cage. And therefore, if this was a 24 cage, plus the 16 on red, this digit would be 5. But that's not 5. 5 has to go in the cage instead. I don't know if that helps. Probably not. 2 has appeared in one of those cells, so grey is not 2. 2 has appeared, 2 has appeared in both of those cells, so violet and green are not 2s. They're a 1, 4 pair. This grey digit is 3, and this light blue is 2. And we're not repeating any of the sums. They're all taken, and in fact we're down to 2 possibilities. 2, 6 pair left in the box. That digit is not 2. No 3 in those cells, so in fact that digit is 3. This is now a 1, 2, 4 set in this row. We're left with a 5, 6 pair in the box. We're left with a 1, 4 pair. Now I might be able to get this by a full X-wing at some point. Let's remove 2 from this cell first. These are all from 3, 4, 5, 6. And one of 5 or 6 must be in use on this yellow pair to add up to 9. The other one is there, so this digit can't be 5 or 6 anymore. This corner digit is now 1, 3, or 4. And there's that digit, 5 or 6. I'm going to make that orange because I know it's the same as this one. Got a 5, 9 pair. I don't think 5 can be here. 5 and 6, in fact, are in use in orange and yellow. So 5 and 6 can't be there. This pair adds up to 6. If it adds up to 6, it's a 4, 2 pair. Oh, if it adds up to 5, I don't know. I've got a 1, 4 pair looking at that cell, so that can't be 4. Now 5 has to be in one of these cells. Oh, this column, 5 and 6 have been used in orange and yellow. So this digit is 1, 3, or 4. That's not... What is this? We know what this cage adds up to because we can deduct 14, 21, 23 from 45. So this cage is 22. This one is 24. This is not allowed to be 22 now. So it's not 9, 8, 5. So this digit must be 9 or 8 that's outside the cage. And in fact, 7 must now be in the cage. It's either 20 or 21. I don't think there are any other cages or lines that I'm missing. So I can't really go further than that deduction at the moment. It's very neat, isn't it, this puzzle? If that was a 5, this wouldn't be allowed to be a 1, 4 pair because of this digit. So, and it also wouldn't be allowed to be a 2, 3 pair because of this digit. So it's not a 5. Red is 6. Orange is 5. 6 down here has to be a 4, 2 pair. And that's huge because that means this is a 3, 6 pair and this is 1 in the corner. That's a 4 now. And this pair can't be 5, 1, and that's also 4, 2. This digit is now a 1 in box 8. This digit is a 4. We've attributed colours and everything. Let's remove all the colours from the puzzle. There we go. That's a 6. Now, we've got 1. We can place 3 in this box. We've got 1, 6, and 8 left in those cells. This one can't be a 6. In the top row, that is not 1 or 2 anymore. It is now definitely 2. We've got 2 1s in corners, no 3s. That 2, 4 pair is done completely. We still don't know what this is. It doesn't really matter anymore. This is a 1, 5, 6 triple. I know where 6 goes. Then I know where 6 goes in box 3. 4, 3, 2, 1, 4, 2, 3, 5, 7, 8, 9. Okay, I don't really know much about that. 4 there, that's good. That places 2 and 4. Something down here must have happened. 2, 4 pair and a 2 there. One of these is a 2. That's not quite what I was looking for. Maybe this box. 1, 2, 4, 7, 8. 6 and 5. Look at that 1, 5 pair. 5 and 6 are in that pair. 3 and 9 are in this one. That's giving me an X-wing. There's other ways I could have worked out 3s in one of these 2 cells, but it'll do. In this column, this digit sees 4 and a 1 in that pair. So that's a 2. Oh, I could just have finished off the I-wing in column 6. That's a 1. That's a 4. That was pretty straightforward. Right. I should also remove the coloured lines, shouldn't I? Because they were just an addition I put in to aid mémoire me as we went along. There we go. Now, this is just Sudoku left. In this row, we've got 4, 1, 2, 5. This can't be 6, 7, or 9. This digit is 3 or 8. There's only one... No, there's not only one place for 7 in the row. There are 2. That's wrong. How about that 3? Oh no, this 5, that translates up to the top of the grid. We get a 9 there, and this digit can't be 9. And that ran out in a hurry. 3956. These are from, where's 6 in the bottom row? It can't be in those cells because of this 6-7 pair where I haven't removed the line. There we go. So 6 is in one of these two. No, it's not in one of those two. Sorry, it's got to be here. That's what I'm concluding. This digit is 5. That means this is a 3-5 pair. This digit is an 8. That's, sorry, blindingly obvious now. This pair is a 1-2 pair. I know the order from the 1 slightly higher up. That gives me 2-6. That gives me 6-3. I see this working now. 3-5 there. This digit is 5. This one, which was 8 or 9, can't be 8 now. So this pair is 7 and 8. And that 5 has sorted out 1-5, which sorts out 1-8, and we can run that back, get 7-8 and 7-9. That 1 is giving us 1-4. That gives us 4-2. That gives us 2-7. That places 7 in this cage, and then we can do 9 and 8, thanks to the pencil marking. The 9 gives me 9-3. We'll take that back to 3-6, and then 7-6. And that is the solution. All the sums are taken, and it's a beautiful construction. Oh, loads of people have done that. So it's been a popular puzzle, and I'm not surprised. It's very clever. Really enjoyable Sudoku by Phoenix Aki. And I think Sujoiku will have been delighted to receive that as his Secret Santa Christmas present. Thank you for watching us on the channel. Always such a pleasure to have you with us. We appreciate the privilege of you occasionally dipping your toes into our stuff. But come back tomorrow, there'll be more. See you then. Bye for now.